Hello everyone, hope you all are fine, and today first I will be discussing the question paper and I hope you all are sitting with the answers. I have the question paper with me. I'll discuss the answers and you make sure you are sitting with your answer sheet. It was of a 12 marks test and the first question is, what is octet? Octet is having complete valence or 8 electron at its valence shell other than K shell. You need to mention other than K shell. It is 8 electron at the valence shell. It's called octet. Give example of an anion with octet. It can be O2 minus, that is oxide ion, nitride ion, N3 minus, F minus, anyone you can write. And a cation with duplet, Li plus, it can be an example. Be2 plus, that is beryllium dipositive ion, anyone. So that was having 3 marks, 1 mark for the definition of octet, then 1 for these 2 examples asked. So 1 plus 2. Draw orbital picture diagram. I am not showing, you all know how to draw. Just make sure the electron counts has to be correct. There is no mark for giving beautiful drawing, decorations, colors. It's not a drawing class. What it has to be, it has to be neat and clean, and the number of electron has to be proper in the valence shell. Like in magnesium chloride, magnesium has 2 electron at its valence shell, which one it is giving to 2 different chlorine atoms. So after donating the electron, the magnesium octet has to be filled up. That is magnesium electronic configuration, as you all know, it's 282. So after giving 2 electron, it has to show 28. And chlorines has to show after accepting both the chlorine 288. These things has to be corrected. Ammonia is having covalent bonds. So you need to show 3 covalent bonds, that 1-1 pair means 1-1 sharing, that is 3 electrons share. And after the sharing, when you are showing the ammonia molecule there, every atom must completed its octet, like nitrogen, including the sharing of electrons, has to be 8 and hydrogen has to be 2, and nitrogen's 2 electrons which have not taken part in the bonding, you need to show them also very much clearly. So this has to be correct. To 2 marks, 1 plus for each. Question number 3, X2 minus has 16 protons and 16 neutrons. The proton and neutrons are those subatomic particles which do not take part in any chemical reaction and they remain fixed during a course of a chemical reaction and they are in the nucleus. So they are only the basis of any atom or identification key of any atom, like a fingerprints, number of protons which is unique. And X2 minus has X 16 proton, 16 neutron. Give its electronic configuration. Its electronic configuration means X2 minus electronic configuration you need to give. Not of X. You need to give electronic configuration of X2 minus. So X2 minus means it has accepted 2 electron. 16 proton means the atom, when the atom is in a neutral state, it has 16 electron. But here in X2 minus, it has accepted 2 electrons. So the electronic configuration will be 288. The answer will be 288. And state nuclide symbol of X. So when you are writing nuclide symbol of X, so atomic number you need to write as a suffix and or subscript, and in the superscript we write the mass number. So atomic number 16 and mass number is atomic number, that means a neutron number, a proton number plus neutron number. So 16 plus 16, 32. So X 16, 32. Though it is very much clear from the number of protons and neutrons that this element is actually sulfur, but you are not allowed to write S. You will be mentioning the symbol as X, because they have given in question paper symbol of X, nuclide symbol of X. It's not written here that identify the element and give its nuclide symbol. So do not identify X and then 1632. So 2 marks for 2 answers. Define isotope with example. So many times we are doing, I think from class 6 or 7. Isotopes are the atoms of same elements having same atomic number but different mass number. Example means minimum a pair you need to mention. Do not write only one atom, like H11 is an example, or C612 is an example, or chlorine 1735 is an example. Do not do so. You need to give the pair like H11, H12. Minimum 2 you can give 3 H13, or you can give carbon 612, 613, 614. Any minimum 2. Question number 5, the 2 marks were there, one for definition, one for example, one for correct pair, and as you all know there is no half marking, so no half marking will be considered here. State 2 differences between electrovalent bond and covalent bond. So first difference is electrovalent bond is formed by transfer of electron, and covalent bond formed by sharing of electrons. Then you can write that in electrovalent bonds generally metal and non-metal involves, but in covalent bonds generally non-metals are involved. You can write these 2 points. State a reason for chemical activity of an atom. One only asked, so you can write to attain the nearest noble gas structure, or you can write to attain the duplet or octet, or you can write to gain a better stability by accepting a donating electron and by joining with other atom. I think stability word is very much relative, so you can avoid this term stability. Better you can write to achieve nearest noble gas structure or to achieve octet and duplet. That will be better to answer. So this is a 12 mark question paper. I hope you all have now understood what are the type of question that will be there in your examination, and no Rutherford, no Bohr, no Dalton, those are not there in your syllabus. So I hope it's clear now. These are the type of question, and some more type of question we will discuss because we have a lot of time, and periodic table is also we have discussed because in our syllabus we have only the laws of the periodic table, and then we have simple ideas about the groups, periods and the periodic table, only about the 4 groups. Last day I was talking about periodic properties. Today I will not start in detail. I just want to give a highlight of the periodic property. The periodic properties are the properties of the elements which repeated at the certain interval in a periodic table. In a certain interval, if it repeats, a repeating property, like metallic property. Previous day as we were discussing, at a certain interval it repeats, so it's a periodic property. Then electronegativity, we know at the end of every period the elements or the atoms which are present, they are highly electronegative or electropositivity. These are periodic properties. So like this, there are generally 5 periodic properties which we study in class 10 in detail. They are atomic radius, then ionization potential or ionization energy or ionization enthalpy, electron affinity, electronegativity, and metallic non-metallic character. Basically we study their trends means how they are increasing or decreasing across a period and down a group, how it is affecting the elements, how it is affecting the properties or the compound formations, and then a comparative study of the elements based on these properties, their application that we study. Actually previously we used to study it in class 9. In class 9 half yearly we used to have this class 10's chapter, but as we know now that things are a bit different, so I'm not going to elaborate those all in detail. We will start a discussion about this in the next class, and parallelly we will be discussing the question answers also, because we are almost at the end. Few terms which are there in the periodic table, like heavy elements and the light elements. Heavy elements are those elements having neutron by proton ratio more than 1.5. They have a tendency to decay alpha, beta, gamma radiation from them. They are actually called radioactive elements till they convert into lead. Lead is having N by P ratio equal to 1.5. So in the radioactive mines, lead deposits are found. It is there in your physics, modern physics, I think. We'll read it later on. So this is a term, heavy elements. Example like uranium, radium, and those elements having neutron by proton ratio, that is N by P more than 1.5, they are all generally radioactive elements. As we know, the Mercury who first worked on this, and radium, and then polonium. She is the only one who got Nobel Prize both in physics and in chemistry. And Marie Curie's, whenever I talk about, an interesting fact is that she is Nobel laureate, has got 2 Nobel Prizes, one herself, another with her husband Pierre Curie, one in physics, one is chemistry. So she is Nobel laureate, her husband is Nobel laureate, her daughters are Nobel laureates, and son-in-laws are also Nobel laureates. So Nobel family, like Nobel gas family. You can read about Marie Curie. Actually, Eve Curie, her daughter, has written a biography on her mother. You can read that book. It's available both in English and in Bengali. I read when I was in school, I think in class 3 and 4. From Mama Badi, my Dadu suggested me to read. That time I read. Anyway, one more term I just want to say here, it's diagonal relationship. This term is also valid or applicable only for period 2 and period 3. The elements situated diagonally in the period 2 and period 3 like lithium, magnesium, beryllium, aluminium, they show some similarities in the properties due to their similar atomic radius and some other similar properties. They are called having in diagonal relationship. These elements if we talk about boron and silicon, they both of them are showing metalloid. Both of them are metalloid, though boron is in period 2 group 3 and silicon is in period 3 group 4. They are from the different groups, but due to they are having diagonal relationship, they basically show similarities in the properties. So this is another term which is there in the syllabus, and that's about periodic table. Bit of discussion. Next day we'll continue with that. Till then, take care and bye.